Hi art students, it's Miss Bodish and I would like to explain an extra credit assignment that you have available to you now. Um, the extra credit assignment is called Fractal Art Project, so it's just titled Extra Credit and then Fractal Art Project. Right now it's a draft. I have not finalized it, but I will after I make this video. So I am going to strongly encourage that you watch the entire informational video. Notice that's the very first thing in the instructions. And please know that the assignment is optional, but that it would be very, very helpful if you did complete it. And you never know that maybe you'll need those 10 points of extra credit later on down the line at the end of the second trimester. So 10 points might not seem like a lot, but it can certainly boost people a whole letter grade if they're, between grades. It really does help to have the extra credit. And when you finish the assignment, you will be submitting two things. You'll be submitting a fractal design. That's your own fractal design. And you will also be you'll complete the Google form that is attached. Now, the feedback for this form is really important. Some of you may not know, but I am in a master's program, and one of the classes I'm taking is about STEAM, which is science, technology, engineering, art, and mathematics. And I'm learning different methods for integrating mathematics into the art classroom right now. So this fractal design project is like a mock lesson plan, or it's an assignment for me to practice having more math within the art class. And so if you want to work through this assignment and you end up doing the extra credit, the feedback that you provide for me will be analyzed, and I need to write a paper based on the feedback and the projects that people submit. So it's really important that when you do submit the feedback, that you're really thoughtful about it. Again, reading every single thing before you make your selections for the multiple choice. And the multiple choice, there's no wrong answer. Just carefully read everything and answer the multiple choice questions. The short answers, please write in complete sentences and be very thoughtful. If your answers are very short, or if this form is incomplete and it doesn't seem like you actually worked through the project, then you won't be receiving the extra credit. So please make sure that you take really good care and fill out this portion thoughtfully with complete sentences. And a lot of times at the end of the trimester, students will ask if there's extra credit opportunities. Well, they're limited. They're a limited time offer with a due date, right? So our due date is this Saturday at 2 p.m. because my assignment is due Monday. So I need Saturday and Sunday to do the assignment so I can turn it in on time. And I apologize for not giving you guys more time, but I just found out about this assignment a few days ago. So that I will be analyzing your feedback. So anyways, let's look at the fractal assignment. Okay, in the art classroom, our prompt would be coming from a real person that's kind of creating a proposition or requesting us to help them with their design. So here's the letter that we would receive in the art classroom. So art students, it's for us, and then it's from Wolfram Research, and it is about creating fractal art and media design. Okay, so Wolfram Research is a multinational company specializing in computational technology. Stephen Wolfram, the CEO of Wolfram Research, is seeking the help of innovative young artists who also possess keen mathematical minds to help design educational posters and other media that will advertise Wolfram Mathematica. The goal is to have these posters on display in science and math classrooms around the globe. Stephen Wolfram would like the artists to use Wolfram Mathematica software to create their fractal art. The resulting art should be eye-catching and entice viewers to further explore Wolfram Research and its technology platforms. If you are up to this design challenge, please respond to this memo with the following information. Now, you guys don't have to write back Wolfram Mathematica. This would be something that students would do if we actually did this assignment in class. So don't worry about responding to the letter, but consider this letter when you're designing your fractals, because that's really the assignment, is for you to consider Wolfram Mathematica's purpose, meaning they want you to design posters that advertise their company. Thank you for your efforts in this artistic and mathematical endeavor. Advertising Wolfram research, and specifically Wolfram Mathematica, to high school and college students is extremely important for our quest to foster innovative young minds. We look forward to your prompt reply and subsequent fractal design submissions. So let's learn more about fractals, because we need to know what fractals are in order to do this assignment. So fractals are created using a mathematical formula. So let's look at a little bit of fractal art on the internet. Let's see, here's some fractal designs. Okay, you can see that they have a repeating kind of shape, that you see the same shape gets repeated over and over, and you can find natural fractals within Mother Nature, like within ferns. So this formula, it's a mathematical formula, it actually creates natural fractals within, within the world. But you can use the formula to create fractal art. Okay, so these are all examples of fractal art. I don't know about this guy, but all of the ones, these look like really kind of psychedelic, cool fractal art that's made with a mathematical formula. So let's go back and learn about this formula. The Julius set and the Mandelbrot set are both mathematical formulas that some people, if you look it up, they'll kind of use them interchangeably. The names, they'll say Mandelbrot set, but they might actually be showing you the Julius set formula and vice versa. So don't let that confuse you, because they're very similar mathematical formulas. And essentially C within this mathematical formula is the constant, right? So the constant, when it's changed, you can see that the constant is altered just slightly here when C is 0.6. Then the fractal looks like this. When C is 0.65, the fractal changes just a little bit, and again to 0.7, and again to 0.75. So you see how the fractal art is changing based on how the formula changes. Okay, so we're looking at a complex number here, and a complex number consists of a real part and an imaginary part. We can consider a complex number as a point, like x, y, in a two-dimensional space, so the coordinates of a point. And I don't know if you guys have studied like graphing any math. I don't know if you've done this within your math classes yet. This mathematical portion of the assignment may be a little too advanced for some of you, but essentially, if we consider a complex number as a point that you can graph, I've selected randomly, I've selected 0.8 and negative 0.8, which is down here. Okay, then essentially, the x-coordinate is the real number and the y-coordinate is the imaginary number. So a complex number consists of a real number and an imaginary number together, which makes this a complex number. And to be simpler, a complex number is simply a pair of coordinates like x, y on a graph or on a two-dimensional plane. Okay, so if we take this coordinate that we've randomly chosen, which is 0.8 and negative 0.8, if we take this and we plug it in here, we make this z, and we choose a random constant. We're going to choose 0.5 as our random constant, or negative 0.5 as our random constant. Then we can create iterations. And what that means is that we have to make compute this many times in order to create the fractal. Because essentially, when you look at fractals, where were we? Here here we were, they're a repeated shape or a repeated like little, you see how this little like section's repeated here, it's repeated here, it's repeated here, and it's smaller and smaller and smaller, right? So you need to continually compute the same formula over and over in order to generate that repeated fractal art, essentially. So here we are, we're plugging 0.8 and negative 0.8 into the formula, and we're using 0.5 as our negative 0.5 as our constant in the formula, and that is just randomly chosen because you saw up here where C was different numbers, right? And in the fractal world, if you start developing your own fractals, there'll be fractal generating apps that you can just plug in C, whatever C you want, whichever constant you want, and then you can visually see how having different constants, different numbers here will change your fractals. Anyways, you get out of this, when you input these coordinates, you will get out Z2, which is these new coordinates. Now, then you need Z2 in order to generate Z3, and you need Z3 in order to generate, and you'll plug that in here, in order to generate Z4. And you need Z4, which you plug in here, in order to generate Z5. Okay, so the Julia set formula is an iterative formula, which means that it's continually like replicating itself and building upon itself. And the results of each calculation needs to again be put into the formula for the next calculation. So the process is repeated. So that means that Z2 is calculated by using Z1, and Z3 is calculated by using Z2, and so on and so forth. Now, these random coordinates that I chose have a divergent tendency, which means it just keeps going off and off and off and off and off, and it doesn't stay within a nice place to make a pretty fractal. So I chose kind of bad coordinates. But if you choose coordinates that are more like this, 0.2 and you know, the 0.2 here, this would be like, in the coordinates, it would be like right here. It's a little closer to the center point, and it's up here. So these coordinates will create a convergent calculation, meaning that the fractal is prettier, essentially. And you'll discover this when you start looking into fractal generating applications. So the convergent tendency is here. And the divergent tendency just means the formula is veering further and further from where we want it to go. You can explore more here on wolframalpha.com. And then Wolfram Research is asking you, it says, it's really important. They are carefully considering their proposition to you, and they're saying that they would like for you to modify your fractal design so that it incorporates the following elements. You need to add text to your fractal design via eye-catching advertisement for the company. That means include the company logo, include a slogan, etc. Push your design beyond just using the computer. So what you could do is you could take your design and you could incorporate other images into it, or other backgrounds, or other relevant artists that are important to similar types of art. So I'm going to leave you a list in just a minute, but Wolfram Research says in their next letter to us, they say, fractals are infinitely self-similar. They're iterated and detailed mathematical constructs, having fractal dimensions, of which many examples have been formulated and studied in great depth. Fractals are not limited to geometric patterns, but can also describe processes in time. Some would say that fractals can be viewed as a metaphor for infinity. Wolfram Mathematica believes in the infinite possibilities of the human mind. Our software enables users to construct and explore those very infinite possibilities. Keep the idea of limitlessness and infinity in mind as you revise your designs. We look forward to seeing your finished products. So here's some more things that you could research to add on to your fractal design. You could research any of these additional pieces of information. There's some artists here, there's some art movements, and some of these artists are optical artists. There's a whole movement called op art or optical art. And then there's some websites that you can also look into if you wanted to further research different fractal art. I would suggest that you download a free app to make your fractal art. That would be a really easy and fun thing to do. Don't pay for anything. You can find free software or find free applications that are, will help you make your free fractal art. Here's another one, Fast Frac. And some of these will even show you how you're computing these using the calculations with the Julia set or the Mandelbrot set. Here is Wolfram Mathematica's website, so you can see that it's a highly visually appealing website, so they do care about design and design aesthetics, and they really are looking for you to create a poster design using fractal art to advertise Wolfram Mathematica, which is part of the overall Wolfram Research Company. So that's just a little bit behind this project. Good luck, and I really, really hope that you will participate in this assignment. If you have questions, pop into my open office hours on Wednesday at lunch. And remember, it's due by Saturday. So the sooner you get it turned in, the better. Thanks.